Yeah, so today, what I want to talk about is not just ThreadFix, and I'll go into detail for folks who might not know what ThreadFix is, but I want to talk about the ecosystem that we've built around it. So ThreadFix is an open source application level vulnerability management platform. So it consists of a central server as well as a number of other plugins. And because it's an open source, we have the community edition that's open source, that's allowed us to interact with a number of different organizations and individuals in what I think are a really beneficial way. And so what I'd like to do today is talk through and provide, again, a little bit of a background about ThreadFix, but really to highlight a number of contributions that different companies and individuals have made, and then to provide some thoughts about what we've done well, what we've done not as well, and a lot of the benefits that we've had in taking that approach to releasing this software and growing that over time. I've been provided by my business partner John Dixon has provided me with a list of words and hand gestures that I'm no longer allowed to use in presentations. So we'll I'm not gonna fall for that. Yeah. Catch me afterward, and we can discuss. But hopefully we'll do well with that. That's a picture of me. My background, just to provide for some context, I'm one of the founders of, I'm the CTO of Denim Group, and I'm a software developer by background. And so I started in the mid to late 90s doing a lot of early server-side Java stuff, spent the early 2000s doing some early .NET stuff. But really for the last decade, I've spent my professional endeavor as well as a lot of my personal interest has been looking at how software developers and the code that they write impacts the security of the organizations that go and actually field and deploy that software. And so my background is that of a software developer who's come into the world of security as opposed to someone with a more traditional network pen testing background that's now looking at web applications and mobile applications. And so that kind of colors a lot of my thinking, and I think has fed into ThreadFix, because a big thing that we try to do with ThreadFix is to say, let's take all the stuff that these security tools are producing and let's push it into the tools that the developers are already using. Let's take friction out of the process of fixing code so that developers can get more things fixed faster. Also, by way of biography, I help run the OWASP San Antonio chapter. So is anybody here from San Antonio? All right, there we go. One in the back. Fantastic. So agenda, I want to talk a little bit about what ThreadFix is, just for people that you may not know or may not have that background. Then I want to talk about some interactions we've had with the U.S. Department of Homeland Security, specifically in their SBIR and their Small Business Innovation and Research program, and go through some of the things that we've done with them, the benefits of that, and how we've rolled the work that we've done with them out into the ThreadFix platform. I want to highlight a couple of vendors that we've worked with that have helped us with this project. And then I want to go through a couple of different both corporate and individual supporters, organizations and individuals that we've had the opportunity to work with. And then I want to talk about what's next. And a disclaimer for this is this presentation reflects my opinions. This shouldn't be perceived as being endorsed by the DHS, endorsed by the sponsors, contributors, supporters. This is me talking about publicly available stuff, but any sauce that I throw on anything or any color that I provide is mine. Please don't perceive this as being an official endorsement from any of the folks that I'm talking about here. So what ThreadFix is it is a application level vulnerability management platform. So when I say application level, it's focused on the types of tools that you use for application security. Focused on pulling in results from static analysis, from dynamic analysis, now IAST stuff as well as your manual pen testing results and things of that nature. We have some support for network and infrastructure and that stuff that's being built out, but the folks that use ThreadFix typically tend to be on the application security side of the house to manage that type of those type of results. And what ThreadFix lets you do is it first lets you create a consolidated view of all the applications in your portfolio and the vulnerabilities you've identified in them. Provides you some tools to prioritize application risk based on data. And then the goal after that is to translate these vulnerabilities, which you find on the security side, over into the tools that the developers are already using. And so when I say a consolidated view of applications and vulnerabilities, it lets you lay out, here's the portfolio, here's all the teams we have in our organization, here's all the applications each of those is responsible for. And for all of the testing activities that you're doing, if you're doing static analysis, dynamic analysis, if you're using third-party pen testers, if you're you use some of the network or the SaaS-based testing services, the idea is to take each of those data sources that in most organizations exist as silos of data, and to roll that up into one unified view. What we found is and the thing that really led us to create ThreadFix originally was we found that even moderately sophisticated application security programs tend to be multi-vendor, multi-activity. The programs that only use large vendor XYZ tend to exist solely in those vendors' white papers, don't actually exist in the real world of people that are trying to solve problems. And of course, organizations say, well, most of our stuff is in here, but for these guys, we're using some other stuff. For these applications, we're using other stuff. And the challenge that we saw was there wasn't those vendors don't necessarily have an incentive to play well together, right? Their argument is, well, if you're using their static and our dynamic, why don't you just switch your static tool over to ours, right? And the server-based tools, the vulnerability management platforms or applications that they provide, again, are focused on managing data from the tools that they provide. And so that we saw a disconnect between the real world or client organizations that we worked with and the solutions that were being provided by the different vendors in the space. Once you've got, and so the idea is, again, load all this data in, clean up the data, and give you one unified view. Next, we want folks to be able to prioritize application risk decisions based on data. Like, risk decisions aren't made by tools, risk decisions are made by people, looking and making decisions. What we want to provide is a set of tools that let you slice and dice the data from all these different data feeds and make decisions about, well, here's how I want to package this stuff together. These are the things I need to do first. These are the things I'm really scared about. Once you've done that, a big focus of ours is take the vulnerabilities that security people care about and move those into the tools developers are already using. It's hard enough to get developers to do anything for you, right? I mean, and what we saw were a lot of really negative interaction patterns. Run a scan, generate a 300-page PDF with a color graph on the front page. Put sticky notes on the really bad stuff and hand it off to developers. Or if you've got multiple tools, copy everything in an Excel spreadsheet and hand that to the developer. Not helpful. So what we want to do is take all this security data and put in the tools, but also frame it in the constructs that developers are going to care about. And the goal with this is to take friction out of the remediation process. You want to make it as easy as possible for the developers to do the things that you want them to do. And by doing that, you get the developers to actually hopefully do some of the things you want them to do and to do more of it. Just to give a super quick demo to show kind of what that workflow looks like. So inside of ThreadFix, you've got your portfolio, and the resolution here is not great. With the different applications, we can drill into a specific application. We've loaded a bunch of vulnerability data in here, either manually uploading it. We've also got a pretty extensive REST interface and some other plugins and things that make it easy to load in data. From this, you can then go in and say, well, I want to package these 7 cross-site scripting vulnerabilities together, and I want to send those over as one unit, as one defect to the developers using this JIRA system. Right? So now these vulnerabilities live alongside all of the other work the developer has to do. Right? They've got new features, they've got non-security related bugs, and they've got these 7 security changes that I need you to make to fix these vulnerabilities. ThreadFix goes out and keeps track of the status of those. So on the security side, you can see when the developers think that they've finished things, rerun scans, and determine, hey, were the developers successful doing this or not? And as you do that across all the different technologies, as well as all of the manual testing that you're doing, that gives you a lot of good data so that you can start to slice and dice and say, for this, for all the vulnerabilities we have in our enterprise right now, show me ones that are an application subject to PCI, that are external facing, where I did my testing on a production system, and only look at the criticals and highs. And I want you to show me, we've got a policy that says we can't have vulnerabilities more than 30 days old. And so that lets you, after I did all that, as luck would have it, you can save those queries, which I have done. Haha. And so now we've got, now that's the set of vulnerabilities that we're looking at. So we've taken all the things that we've found and drilled into that. And so what we want to let folks do is ask a much more sophisticated and quantitative set of questions about their software security programs across all the different tools or technologies they might be using. Any questions so far? Excellent. All right. And so we released ThreadFix. We started developing it about 6 years ago, and we released it. I can't remember exactly when, but we made the decision that we wanted this to be an open source platform for a number of reasons. And what that gives us is the ability to reach out and to work with people and organizations in ways that we couldn't otherwise. And we do other commercial stuff around it that this is not the place to talk about that. But we thought that having that open source community edition provided a lot of really good options. So some of the things we did to try and foster community, we released it under an open source Mozilla license, which we perceive that some organizations, like bigger enterprises, might have a problem with GPL-based code. Some do, some don't. I'll talk a little bit more about that later. We moved the hosting to GitHub, which is nice because people can fork it, do stuff, make changes in their environment, possibly submit over pull requests. We've got a Google group that we use to do discussions and things. A big thing that we did, and this is not necessarily an open source thing, but certainly speaks to community, is we exposed what we consider to be a pretty extensive REST API. And as we'll see, that's one of the things where we've been able to drive a lot of innovation by exposing that API and seeing both what people do with it as well as what people are aggravated that they can't do with it. That's a great source for us of feedback from the community. And then we've also got a contribution model where folks can extend things in the way that they'd like, and we've got a structured way for them to get those included in the mainline branch so that it's maintained along with everything else. What are folks doing with this? This is more just for the slides. If folks want to pull them up, you can look and see what different organizations are doing. But the common pattern that we see is, again, we've got these different data feeds of testing activities. Those feed through the ThreadFix platform and then get sent out to other places. And again, by having that central location where all this data flows through, that gives you the ability to speak in a much more quantitative way about what you're doing with your application security program. And it gives you the ability to ask a very sophisticated set of questions about that data, which is great when your manager comes in and says, hey, my boss read something, read like an airline magazine thing. I need to know how many applications we have that do X, Y, Z, or I need to know how many vulnerabilities that we have that do this stuff. That puts you in a situation where you can quickly, it gives you the tools to go quickly answer those questions so that you can go back to doing actual valuable work. One of the really incredible relationships that we've had is with the U.S. Department of Homeland Security, and we're currently in a phase 2, the second year of a phase 2 of a DHS S&T SBIR, or SBIR. For those of you that speak English, DHS is obviously the U.S. Department of Homeland Security. The specific group at Homeland Security where we are working with is the Directorate of Science and Technology. And the program under which we're working with them is the SBIR, Small Business Innovation Research. And what that does is basically the government, and this is not just the DHS that does this, a number of federal agencies do this, but they will say, these are the technologies that we think that the government customers are going to need. And we've got a structured way to say, here's phase 1, will this, if you have an idea to do this, will it actually work? Phase 2, actually build it out so that you can do stuff with it and then beyond. And what we did is we noticed a solicitation that had gone out from the government that talked about merging static and dynamic results, right? How do we take, if I got static testing and dynamic testing, how do I get a unified view based on those results? And so we submitted a proposal to build what we call hybrid analysis mapping. And what we've done, we obviously won an award, and a phase 2 award, or else this slide would be blank. So we won that award, and we made the decision to include this technology with ThreadFix. So ThreadFix is the base platform, and then we also include this hybrid analysis mapping technology along with the open source platform. And the decision to do that was really what we wanted to do is to get the technology in the hands of as many people as possible. And I think we have been or are being successful with that. And so I'm excited about the stuff that we're doing with the open source hybrid analysis mapping. And as we'll see, that's let us build some components that I think are interesting to a variety of folks. And it provides a way for us to get that in the hands of a lot more people and get more feedback than we would have if we kept the technology closed and worked with one or two organizations specifically as we were developing it. So the goal that we had was to create a system that will merge results from static analysis tools and dynamic analysis tools. So after you've done this analysis, take the results of disparate tools and put them together, which we did, and we found some other things we could do with that technology. And the initial goal was looking at saying for HP Fortify and IBM AppScan, what we saw is a lot of organizations deployed these technologies, and the way that the industry evolved, the way that acquisitions had happened, a lot of organizations that we worked with had Fortify installed, Fortify installs they were rolling out, had AppScan standard installs they were rolling out, and all of a sudden, just the way that the industry rolled up, they've got vendors that aren't necessarily super interested in making those technologies play nice together, which again makes sense. I'm not knocking those vendors, but what we perceived was there's a situation in the market where a lot of organizations had a problem and there wasn't someone out there that had a real incentive to solve it. So that's what we stepped up to. That's what we stepped up to do. But the way that ThreadFix works is the way it normalizes data. If we build this support for one technology, it works for all of them. So we can pull in static results from any of the major, any of the static analysis tools we support, and do this type of correlation with any of the dynamic tools that we support as well. So folks here probably understand this, maybe remedial, but dynamic testing. You first spider the application to figure out what are all the pages that this will respond to, what are all the entry points. Crawl the site like Google would, but obviously with a login capability and session detection. After you've figured out the attack surface of the application, you fuzz it. I'm going to send it a SQL control character if I see a JDBC error message coming back, like, oh, that pattern indicates a SQL injection vulnerability. And what the findings typically look at, or like the way that we normalize this data, is the vulnerability type, which we use the CWE, the relative URL within the application, and then for certain classes of vulnerabilities, also the entry point. And so, for cross-site scripting or SQL injection, what parameter, what get parameter, post parameter, what cookie, what carried the payload that went into the application, versus like a directory indexing turned on or whatever, which you would only need the the CWE and the relative URL. Static analysis works differently in that you give it the source or the binary. It creates a model of the application like a compiler would. And then you perform analysis to look for vulnerabilities and weaknesses, based on data flow analysis, control flow analysis, semantic analysis, and so on. And in this case, what a finding looks like is the vulnerability type, and then the path that the payload takes through the application. And so it's SQL injection that hits this line of code, goes here, goes here, goes here, and then enters a sync function over here. So our sub-goals here that we worked with the DHS on were standardized vulnerability types. We settled on the CWE. CWE is like the democracy of vulnerability taxonomies. It's the worst available one, except for all the other ones, right? we looked at like the 7 pernicious kingdoms, which is just a tremendous name for a vulnerability taxonomy. Having done Fortify training overseas in India and places, pernicious kingdoms is great for non-English speakers. It's real friendly, very approachable, since I don't know what pernicious means. So we looked at a number of them. We looked at creating our own, which would have been even worse, and settled on the MITRE CWE, and that's worked out pretty well. Again, I've got a million things that I could say negative about CWE, but what I can say positive, and the most important thing I can say about CWE is it's worked very well for our purposes, and so as a result, I think that's been a net positive. And a big thing that we need to do here to solve this problem is to match the dynamic attack surface location with the code location associated with that. And certain platforms or certain things make that easy, right? If you're looking at PHP without a framework, you say, well, index.php or /admin/index.php, well, that URL probably corresponds with the file where that's located, right? If you look at things like Ruby on Rails or Java Spring, there's a disconnect, right? You have a lot more variability in the way that code gets essentially like glued to the internet to listen to requests. And then finally for us, we need to be able to do static parameter parsing. Again, to deal with those situations where you've got these entry points into the application, we need a way to correlate the parameter in the dynamic request with the specific location in the line of code, the function call where that data or where that tainted data comes into the application. To do this, we need the source code, or we don't need the source code. The results are way better with the source code. And what we do is detect the framework type. Right now, we support Java for JSP, Spring, and Struts. We support C# for .NET Web Forms and .NET MVC. We support Ruby on Rails, and like right now, we're working on PHP. Which will be a lot of fun, I'm sure. And some of the static analysis tools provide hints that help with this as well. And so if that data is available, we'll consume it. But the typical use case is us having access to the source code and building this attack surface model. And what we build is what we call the endpoint database that keeps track of, here's the URL and the parameter. Here's the list of all the URLs and parameters that the application should expose. And here's, for each of those, the entry point in the source code, the source file on the line where this tainted data, or where this touches the, touches the network. And we do that by very lightweight static analysis, where we go and we detect the language and platform. And based on knowledge of how the language and platform exposes this stuff, we say, oh, well, in Spring, we go through and we parse all the controllers and figure out where is this controller exposed. We parse the models so that we know for the, binding and things like that. We know all these different entry points. And what that gives us is this, big database. And so given this database, we can say, well, I've got a dynamic result for reflected cross-site scripting in login.jsp for the username parameter. And I can query the database and say, what entry point line of code is this? And this is a Java Spring application. We get com.something login controller.java line 62. Then we can look at all the findings that we've got and say, hey, do we have anything that matches reflected cross-site scripting that starts at com.whatever, login controller.java line 62? If we do, we can say, well, here's this dynamic finding that seems to correlate with a static finding. These aren't two vulnerabilities. These are two pieces of information that we have about one vulnerability, so we can correlate those. There's a little bit more that goes into it, but that approach turned out and worked really well for us. It's not magic. I should probably take that line out. That's great. So our research produced what we consider to be a successful and valuable outcome. Yay. And in sitting in a meeting where I was talking with some of the engineers that worked on this, the lead engineer that worked on this, the question came up, okay, well, so we're able to do with a reasonable level of fidelity what we wanted to do. Well, what's the other stuff that we have? Well, we've got this endpoint database. What else can we do with that? We can essentially do like a select star on that database to say, instead of looking for an individual attack surface point, show me all the attack surface that you've got. Or we can short circuit the process we talked about before and say, well, here's a dynamic result. What's the associated line of source code? And given those capabilities, we can take the entire attack surface database and feed that to a dynamic scanner to essentially like jumpstart the spidering process and say, here's all the URLs and parameters that this application is going to respond to. We can also say, I've got this dynamic result, and I know the line of code. Why don't we map that into a developer IDE so that we can give them a better idea of where they need to go to start fixing things in the code. Similarly, we found that we can take this data, and it helps us to feed security backlog data into this tool, SonarQube, that a lot of development teams use to manage their quality backload and their technical debt. And so again, with the scanner seeding, what that lets us do is say, hey, if I know all the attack surface, I might know about things that a spider's not going to find, like pages, like landing pages that link into the application, but there's no links out. If you have unused parameters, like backdoor parameters. I once worked on a cold fusion application where for every page in the application, if you pass in a parameter named D, whatever value D had, if you pass in a value of D that was like 1, 2, 3, 4, 5, it would delete order number 1, 2, 3, 4, 5, right? And I don't know if that, I prefer to think it was a utility function that a clever developer accidentally cut and pasted in all his code, or it might be a backdoor, right? Who knows, right? But the idea is if you can precede the scanner with all of this data, that gives you an ability to reduce false negatives by getting a more thorough scan. So it increases your scan coverage. We've currently got plugins for OWASP Zap and for Burp Suite, and right now we're also building one out for IBM Rational App Scan, and that's in progress right now. And just to give you an idea of what that looks like, I'm not sure with the resolution here if this is going to be. So for Burp Suite, what we can do is go and basically point it at the source code, pulls it in, the spider runs, and then what we see here is we would find pages like this admin.jsp. So for an unauthenticated crawl, you wouldn't know that that admin page was there. You're not going to have any anchor tags or links into that. And similarly, we find on a number of pages we've got this debug parameter, again, that you wouldn't find with a crawl, but that is going to affect the application's behavior. And so by preceding the application, what you have is a better knowledge of the application. We're also starting to do some things with like authentication and authorization that I think will be interesting. But at the very basic level, you can get this type of knowledge. And we originally had this built such that you had to have a ThreadFix server set up to pull that data in, but now we've embedded the hybrid analysis mapping technology in the plugins. And so if you're using Burp Suite or Zap, you can use the plugin, and if you have access to source code, you can precede your application test scans. You don't have to set up a ThreadFix server. You can just pull the stuff in and go. And so we're trying to help pen testers there. And this is a cool additional use of the technology. And that was one of the great things about working with DHS. And I'll talk more about this. Like, we probably wouldn't have built this technology if we hadn't been able to work with DHS like this. By releasing it open source, that lets us get it in more folks' hands. And so I think that's a net positive for everybody. I think it's interesting to start looking at like what all can we do with source code assisted pen testing. This is one particular transfer, and there's probably other stuff that we can do as well. And again, that's the type of things that we can start to embed in these plugins to provide additional capabilities to folks that are doing web app pen testing. What we can also do is to pull this data. If we've got a dynamic finding and we have a line of code, we can map that into IDEs. And a lot of the static analysis tool have IDE plugins, right? And that's great. I mean, that's fantastic because they are there with the source code. They know the line numbers. They do a fantastic job. And I think that's really good, again, to take a security tool or the security concern of vulnerabilities and to get it into the hands of developers and to get it in the tool that they're using on a day-by-day basis, right? Takes friction out of the process, makes it easier for people to fix things, and it's just a net positive. Sec, dev, ops, rugged, whatever. I mean, like, again, to the degree that we can break down walls between these teams that have different concerns, that's only going to make everybody happier. And again, by embedding this ham technology, that lets us take these dynamic scans and show the entry point line of code. It's not as good as having the full control flow or data flow, which again you'd had if you had both dynamic and static. But even if you only have dynamic, you can say, hey developer, here's the line of code where you need to start looking for where this problem is. Right? Better than nothing, right? It's something that you as security could come and bring to the table for the developers that other than just dumping the vulnerabilities on them, you can say, hey, I'm gonna try to make this easier for you to get what you need to get done. We've currently got plugins for Eclipse and IntelliJ, and we've got the Visual Studio.NET plugin is in progress right now. And just to show you what that looks like. Again, you get little markers on these lines of code that indicate, we've got various problems in there. Much like you'd see again with a static analyzer plugin, but also including the dynamic results alongside that. Any questions about any of this so far? Mm-hmm.
So when you see the plugins, if we run, let's see, app scan, and I have the app scan report, and then we import it to your plugin?
Right. With the IDE plugins, you currently have to have a ThreadFix server. In the future, though, what I want to do is to embed the technology in those plugins so that you can say, from the plugin, hey, here's an AppScan XML file, pull that in. Now show me the markers. Again, to make it easier, we did that with the last release for the scanner plugins, and I'd like to do that to IDE plugins as well. So that because right now to use this, you've got to like set up a server, load the result in the server, and then send it to the plugin. That's great if you've got your whole environment set up like that, but it'd be preferable just to be able to say, well, stuff this file in and show me where the stuff is. So.
With the current one, we have ThreadFix running.
Right, that's right. What we also did, is anybody here familiar with SonarQube? A couple of people, good, yeah. I wasn't because I'm a dummy. But I looked around and I've noticed that our software development practice, those folks were using SonarQube and they use it for all their backlog tracking. And what that let them do is to see, hey, here's the amount of like quality defects that we have. Let's start to make decisions of how much of this technical debt that we want to pay down. And so what we did with our SonarQube plugin is said, let's take all this security data, consolidate it, and then funnel that over to SonarQube so that the security technical debt can live alongside quality or other technical debt. Again, giving for the developers that are consuming this, this gives them one location where they can go to find this data. And we've actually got one implementation we're working on right now where the security team is consuming the results of their security testing through the developer's SonarQube environment. Right, so that's usually it's like, hey, developers, look at our XYZ security portal over here. These folks are taking the other way and said, let's do all the security testing, funnel that data through ThreadFix over to SonarQube, and the security people will consume their data from inside there, which I think is really cool. And also SonarQube, the most recent version of the plugins don't require this, but the previous and kind of the installed base does, where you have to have a line of code to attach a finding to. And so what we can do is use our ham technology to take a dynamic result, map it to a line of code, and then it has a place to live inside of SonarQube. So that's just a view of what that looks like. And so this was really cool to have the opportunity to interact with the DHS folks in this way. I would argue this is a great use of the SBIR program. I have a somewhat biased opinion, and speaking for myself, not for them, but this is a technology that we it's a technology that we thought was interesting, but probably wouldn't have made the investment in to outright. And so this gave us an opportunity to build out this technology, and by releasing components of that technology open source, that lets us get a lot more feedback from the community. It lets us get a much bigger installed base and hopefully push the state of the art a little bit farther. We've also had the opportunity to interact with a number of different vendors, and I just wanted to highlight two. Virtual Forge is some folks that make a static analysis tool for SAP ABAP code based out of Germany. And this fairly, and I think they would agree, is a niche solution, right? Like they say this is the language, this is the environment that we do security testing for. They wrote an implementation to pull their results into ThreadFix so that allows their clients to view their data alongside the results of all the other testing activities they're doing. If you look across your portfolio, you've got some subset of the applications that are SAP ABAP. You've probably got a bunch of other applications that are doing that are written in other stuff that you're testing with other tools. And so the value for them was to say, hey, we can make our results more valuable because we can give you one location that all this data can roll up into so that you can make a decision. Are we fixing the ABAP vulnerabilities, or are we fixing the cross-site scripting in the Java Spring application? Similarly, the Riverbed folks that have since been, that group was sold over to Brocade, they've got their web application firewall. One of the things that we can also do is generate web application firewall rules, and they said, hey, we want to give the ability for all of our customers, regardless of the testing technology they're using, we want to give them the ability to generate web app firewall rules to make our sensor technology more valuable for them. And so similarly, they wrote and contributed support or rule generation for that stuff. And so that was really cool. That's a cool way to interact for different vendors to say, given your capabilities, I think that we can make our technology more valuable for our customers. This is a way for us to provide a lot of value to our customers, and so they're willing to contribute code to that common platform. I want to highlight in no particular order a couple of corporate and individual sponsors. I want to preemptively say thank you to all of them. The Rackspace folks, again, longtime contributor open source. I went to school with the original founders. We've known the people over there for a long time. Really, really big on both consuming and contributing to open source, as you may have guessed from their OpenStack participation and whatnot. And they wrote the original support for the version 1 defect tracking system, or agile workload tracking system. Which is really cool because then a number of other customers said, oh, we're starting to use version 1 for XYZ. And so their contribution, again, that let them solve a problem in their particular environment. Now other users of ThreadFix can benefit from that as well. The Axway folks similarly wrote some initial connection stuff for Fortify SSC that we're in the process of integrating. And they also have started, we've got a widget API for the dashboard components, and they say, well, here's the KPIs that we track, that are different than the standard stuff that you guys have, but we'll contribute these as well so that, so that other people that may want to view the data through this lens can take advantage of that as well. Again, fantastic interaction and ability for us to work with them to make the product better and ultimately make the product better for everyone. Brandon Spruth is a guy who writes some code under the Automation Domination banner. He did the Jenkins plugin. Again, how do we get this into developers' tools? This is great. He wrote a Jenkins plugin that says if you're doing any security testing in your CI pipeline, it lets you grab all the results of that and stuff that up into the ThreadFix server. And so you can get a much, if you're getting the benefit of the quick vulnerability detection time by pushing testing into your integration pipeline, you can get benefit. You can make sure that that data gets rolled up alongside all the other security data. And we've got a couple things that we're looking at doing with the Jenkins plugin. I think it'll be really cool, allowing you to stop builds if you have new vulns and things like that. And so that's great because that's that reflects his view of how do we get all this DevOps and continuous integration stuff, right? He said, well, this is what I need in my particular environment. He wrote it and made it available, which is which is fantastic. Next up, the Samsung folks, and Oleg and Sanjay are here. I don't know. Yeah, there. Okay. Yeah. They did some really wrote a bunch of code for features that they wanted, and then made that available back to the product. And the funny story about that, we were looking through, and they did some very convenient things. Like, hey, when we're doing defect submissions, we want all these defaults, and we want to be able to send out these scheduled email reports. We want to do we want to make the defect. We want to be able to template the defects that we create so that we can show different data to the developers, and and we want to be able to submit stuff from different pages. And so they had some of their folks write it, and we had a phone call with them where we were trying to figure out, okay, well, let's see what you're doing. Let's make sure this fits in the main line, how we're going to be able to support it. And we get through, they demonstrated what they did, and I don't know, maybe a third or half of the way through the call, Mac, who's the lead engineer on ThreadFix, hits the mute button. He's like, these guys did a lot of work. And I was like, yeah, they knocked out a whole bunch of stuff on your 2.3, on your 2.3 roadmap. You guys can goof off for a couple weeks now. And so that was just really cool. Again, thanks to Oleg and Sanjay and Jeffrey, who's their colleague that wrote a lot of the stuff. Again, that was really cool. And what I'll say about the stuff from Samsung and the stuff from Pearson that I'll talk about in just a minute, those are really great because those reflect the real world use cases. And so we briefed Gartner about what we're doing, and all the stuff that we're talking about. There's no this stuff isn't Gartner worthy, right? We're not saying hey Gartner, 2.3 is going to have templating, right? And I was about to make one of those gestures that John Dixon told me not to, but I stopped myself. Gartner doesn't care about this. Gartner doesn't care about this, but customers do. And
Gartner's Magic Quadrant somewhere?
We don't fit into it really well because we're not a testing tool. But in the latest report, I know one or two of the vendors talk about well, we don't have this capability natively, but we provide this to our customers by teaming with ThreadFix. And so we're not a good fit for the AST Magic Quadrant, but a number of the vendors have said we're not natively doing that, but you can get that capability with our product by combining it with the ThreadFix platform, which is cool. The Pearson folks also sponsored a number of different features that'll be coming out here in the 2.3 branch, and have also developed a number of different tools that they've open sourced around this. And that's why I talk about ThreadFix as a platform. It's it's not just the central server. It's the Jenkins plugin. It's the scanner plugins. It's the IDE plugins. It's some of these utilities that they've built, and they've also done a great job of making our documentation less crappy, which I believe gets around John Dixon's word requirements for my presentations. Yeah, that's a technical term. And you can see a lot of this. Aaron Weave and Matt Tesoro's presentation at AppSec EU talks about what they're doing, of which ThreadFix is a component. I think that Matt Tesoro did his 2-day class, the DevOps pipeline or whatever. I think that ThreadFix is one of the technology he mentions in there, which is great. Matt wrote a Go client library. His colleague Adam Parson wrote a Python client library. Matt's also written some utilities to support integrating technologies that they're using. And so, and again, like this is a bit of an eye chart, and you can see this online. But like none of this stuff is stuff that Gartner's going to get excited about. But what it really reflects for us is, especially if you look at all these like REST API calls that we added, like number one, that tells me that we need to do a better job of being API first. That's on us. But what it also shows is by having this open architecture and this discussion with the community, it puts us in a position to let them push innovation for us. Right? I've got a bunch of smart people that I work with, right? But we're not Steve Jobs, right? Like I can't look like over the horizon and be like, you know what everybody needs? They need an iPhone, right? And then you got to put apps on it. That's going to create this giant economy and like music. And like I'm not that smart, and some of the people who work for me might be that smart, but they're not talking. But the cool thing about having this interaction having this ability to interact with organizations like this and have the contributors ask for and push stuff like this is it lets us be very responsive to what's going to create value for the users of the software. And at the end of the day, those are the people that we need to make happy. I love making the Gartner folks happy. But at the end of the day, our constituent is, for the people that are trying to implement these really, kind of forward-leaning practices, how can we help provide them with the tools and the weapons that they need to be successful doing this stuff? And so, by having this open system, it lets us get innovation by working collaboratively with a lot of folks. So what have we learned? Running an open source project, I saw this on Twitter a while ago. It's not free as in beer or free as in speech, but running a project is free as in puppy, which as a dog lover is great, but it's demanding because you're getting feedback from people. You've got to manage things and whatnot, and we've got just a great set of contributors, which has really made it a joy. Interestingly, we originally moved away from the GPL for the Mozilla. But we haven't had a lot of feedback from the larger enterprises that are using ThreadFix, like worried about it one way or the other. Again, the feedback loop that we have, we need to be more API first, just because there's such a push for innovation, and that's where the people that are doing the really cool stuff. And again, for those links that I had, like way back at the beginning, what are people doing with ThreadFix? I really recommend pull those down. There's videos from talks. From the Pearson folks, from a talk I gave at RSA DevOps Days with Chris Carrillo from Ally Financial, the stuff the Samsung folks are doing. I think we've got a talk I gave at AppSec USA with Steve Springett from Axway. People are doing really cool stuff that we hadn't thought of. And a lot of that comes from having the API and being able to extend that API. And the ultimate thing that we found is having a community helps us drive innovation because we're getting feedback. We don't have to think of all the good ideas. We can just listen to the good ideas and then write the good ideas. And the good ideas come from the people that have problems and are just fighting to solve them. And so to have the ability to tap into that is really fantastic. If you want to contribute, that's great. Let us know what you're interested in so we can help make sure, again, that things fit with the main line. We've got a contributor agreement. The way that it works very similar to the way that MySQL works. We actually stole the MySQL contributor agreement and replaced MySQL with Denim Group. But it's a way for people to contribute, to know that their stuff's going to be available in the open source core, but also to give us the ability to do some other things that we need to do from a commercialization standpoint. And I'm slightly over time, but does anybody have any questions? Yeah.
How do you vet these contributions? Are you thinking about who you'd like to contribute, and then what is your testing process, and contributors do testing too? That's a lot of questions.
Normally it's one per customer, but yeah. Okay, and so the question is really centers around how do we vet contributions and how the testing and stuff that goes around with that. Again, for us to accept code, we've got to have one of those contributor agreements in place. So it's typically an organization or someone that we've talked to and have kind of figured out. The first concern that we have is, will this contribution be generally useful in an environment, or in the environment for everyone, or how can we make this contribution generally useful? Because what we can't do, what is great is when we can get contributions from folks like the Pearson and Samsung and others that I've not in a position to talk about. What's great is when we can get those contributions and enroll them in the mainline. What's scary to me is when somebody says oh no, in our environment all the screens have to be red all the time. I'm like, oh. Yeah. Okay, well not everybody wants the red screens, right? So maybe what we do is we make that you get to pick the color of all your screens, and red is one of the options, right? And so that's kind of the first thing, is just to figure out when people go to the effort to make a contribution, the last thing we want to do is tell them no, right? Because again, it's great to have people with that enthusiasm. and then the way we accept requests is by pull requests in GitHub, and so those can go through kind of the vetting. You know, we go through and do like a manual code review to look like, okay, does their code look like the rest of our code? You know, we look to see if it makes sense, and then that goes into the overall ThreadFix testing where we're doing static analysis, dynamic analysis, and you know, all the other testing and vetting stuff that we get. And if people want to do their own testing, we strongly encourage that, and feel free to reach out. So, I would say it is. I would say it is a cornerstone. I don't think it is the thing, but I look at that as that has opened up a new set of contributions. There's one thing where, hey, I want these features, but there's also, hey, I want these API calls. And so that's allowed us to get additionally more stuff. And really, what it comes down to is when we see what people want to automate, that gives us, that's like getting a great view into the mind of the practitioner. And that's one of the things we've noticed writing connections to other people's technologies. You can see like there's I'm not gonna name it, like one vendor, it's like, okay, well your API was written to support your command line client, and you have the 4 calls that you need for the command line client, but I need these other 2 calls, right? Because I want to do a sensible thing, what I consider to be a sensible thing to do with your API. It doesn't exist in the API because your consumer for the API was an internal customer, you know, which in that organization has since expanded it, but like. That's the challenge, is by being able to open up and to look into the minds what other people are trying to do, that gives a much better perspective than like a bunch of people sitting around the room going like, okay, well, we'll do these API calls. That one sounds kind of hard, so we'll push that to the back burner. But by having the API and by giving people the opportunity to like interact based on that, you get to see what type of automation needs people have. And it goes beyond like, here's what I think you should have, to, oh, that's what you need. Cool, now I understand what you guys are trying to do, and that's again, tremendously valuable insight. Well, okay, I'll be around for a little while if anybody needs anything.
Thank you very much.
Thank you.
This is pretty awesome.
All right, thank you.